So today we will start with Sqoop, which is another Hadoop ecosystem tool. And as I have explained earlier, when if you go back to the main picture, which is in setup Hadoop, not Hadoop core components, sorry. Which is in Hadoop introduction. If you go back to this picture, before setting up any tool, first this picture should come into your mind. First you need to analyze whether the tool is a MapReduce based tool or non-MapReduce based tool. If it is a non-MapReduce based tool, you have to do the impact analysis on the cluster because there can be contention for resources between existing MapReduce tools as well as existing non-MapReduce tools and the new non-MapReduce tools which you are trying to configure. So last week I have explained when within the context of HBase, to accommodate HBase region servers, you have to make some adjustments for your MapReduce memory configurations and CPU configurations. So now we are talking about Sqoop. Again, Sqoop is a MapReduce based tool. So you don't need to evaluate the existing configurations because you will be using SGSS for storage and MapReduce for processing the data. So first you need to think about this picture before setting up any tool using in the Hadoop cluster. That being said, now we'll get into the details of Sqoop. So we'll talk about Sqoop. We'll see the overview of Sqoop, and we will talk about architecture. There are two architectures, Sqoop and Sqoop2, and we'll see how Sqoop and Sqoop2 can be configured using Cloudera Manager. We will talk about Sqoop parameter files and log files, and then we will see the demo. Okay, Sqoop is a MapReduce based tool that can be used to copy data from relational databases to Hadoop and vice versa. So you can copy data from relational databases to Hadoop, as well as copy data from Hadoop to relational databases. Both the directions you can use Sqoop, and it is a MapReduce based tool. It is written in Java and it is open source. It uses JDBC for DB connectivity or database connectivity. So whenever you try to copy data from relational databases into Hadoop, or from Hadoop to relational database, you need to connect to the database, whether it is source or sink. Source means where you are copying data from. Sink means the target where you are copying data to. Whether the relational database is source or sink, to connect to them, you need to have JDBC connectivity. And then it uses MapReduce framework. So for processing data, it uses MapReduce. So this is the Sqoop architecture. Sqoop means Sqoop version 1, and Sqoop2 means latest version, which is still in beta. Okay, and it is primarily command line interface. So there is not much complexity in setting up Sqoop for Sqoop1, and it uses map tasks. So primarily it uses only map only jobs to get the data from either the relational databases to Hadoop or from Hadoop based systems to relational databases. For both the things, Sqoop1 uses map only MapReduce jobs. So there will not be reducers involved in that. So it is map only. It is command line only, so you can only run Sqoop commands from command line. It is not very secure. I will explain why in a moment. And there is no client server. There is only Sqoop itself is just one command line utility. There is no web server or anything involved when it comes to using Sqoop to run these Sqoop export or import, which are used to copy the data. If one have access to Sqoop command, he will have access to all JDBC jars. So to copy the data, we need JDBC jars. So if you have a host which is acting as client, and if Sqoop is installed and if all the Hadoop configurations are there, you need to place JDBC jars to successfully run the Sqoop commands. So once you have JDBC jars on that, and yeah, you have to know the database username and password, it is exposed to whoever have access to that client. So it is not very highly secure. You will understand this point when we actually see the demo and when we see the difference between Sqoop and Sqoop2. I will come back to that again. It is not easily extensible and no separation of duties. So yeah, this is not very relevant for DBS. When it comes to Sqoop, the actual Sqoop core developers are having a tough time to enhance Sqoop for new set of databases. But for administrators, this statement is not relevant. So you can ignore this statement. And yeah, Sqoop2 architecture is like this. So if you keep Sqoop and Sqoop2 beside the side by side, the major difference is this layer. Okay, so it requires a metadata repository. So that all the Sqoop configurations which we can use in Sqoop2 can be stored in metadata. And remember that Sqoop2 is still in beta, and there are many issues, and it is not properly documented. So I will not be doing demo in Sqoop2, but I will show some things in Sqoop2 which are so that you can understand the differences. But as of now, Sqoop2 is not reliable. But the way it is designed is it will have its own metadata repository. So when you have to define something called connectors, and let me show you a Sqoop command, then you will understand. Okay. Let me do application development and so this is the example of a Sqoop command. And if you see, you have to define connect. First of all, you have to have a jar file of whatever database you are copying data from or copying data to, and then you have to provide JDBC URL when you run any Sqoop command, and you have to give the target database, which is MySQL database in this case, both the username and password when you try to run this command. So it is not very secure. So whoever have access to that node will come to know about the database usernames and passwords, and it is not very secure. Whereas in Sqoop2, if you go back to the presentation now, there is something called connector, and administrators can actually set up the connector, and they will give you the connector name. Whoever is the developer and whoever want to run the Sqoop commands from command line interface, they will come to know only about the connector name, and that metadata required for that connector will be stored in this metadata repository, and developers can use this connector information to submit the jobs. So they don't need to know the username and password using which they are trying to connect to the database. They just have to know the connector name, and the mapping between the connector name and the username and password information will be known only to the administrators who are controlling the cluster. Other stakeholders like developers need not know about usernames and passwords. Okay, so this is the main difference between Sqoop1 and Sqoop2 when it comes to this point, not secure. And again, this is the client-server architecture. You have a client, and you have a server, and the server is a web server. But the copying of data will be done only by MapReduce. So the server is only facilitate you an interface between the client and the MapReduce framework. It does not actually do any copying activity. Only MapReduce framework will take care of copying data from source to the sink, depending upon whether you are running import or export. And another difference is Sqoop2 uses both mappers and reducers. So mappers will be used to read the data from the databases, and then reducers will be used to write the data to the target. Whereas in Sqoop1, it's a map-only job, so maps are responsible for both reading data from source and writing to sink. But it has some issues with such as the extensible and those things for Sqoop core developers. So to address that, they come up with this new architecture, and administrators need to be aware of this because if how to tune the performance once they understand these things, they can tune the performance. If otherwise, they might not be able to tune it. So for that reason, administrators need to be aware about the way data is copied between Sqoop and Sqoop2. It uses client-server architecture. It uses map and reduce to copy the data, whereas Sqoop is map only. It is available on web because it uses web server in between. Now you can use Hue or some other web-based tools to actually submit your Sqoop jobs, whereas with Sqoop1, it is not possible. Okay, and again, this statement is primarily for developers of Sqoop, for Sqoop core developers, not even application developers like who work on using the Sqoop. Whoever want to understand Sqoop architecture to modify the code for future enhancements, they need to be aware of this one, but not the administrators. It is highly secure. Developers use clients, admin set up servers, and jar files also will reside on server. Whereas in Sqoop1, wherever you have the Sqoop client, you have to have the JDBC jars. Whereas here, only the server need to have the JDBC jars, and the client need not have. So you can have a firewall between this one and this one, and open only port where the client can communicate to Sqoop server. And then developers or production support guys can actually submit the jobs, which will use the information that is there on the Sqoop server. Okay, so now we will get into more details about Sqoop import and Sqoop export, how it runs, because at times even administrators might have to submit the jobs. So unless they are familiar with the architecture, they will not be able to create the commands properly. So I'm spending some time getting into details about Sqoop algorithms. Okay, so at the higher level, there are two main commands in Sqoop. One is import. Import will actually copy the data. Yeah, so that is the first thing which I have explained. If you follow, if you have followed, I started with this presentation. Where is it? Hadoop introduction. I started with this picture. And I have explained that it uses HDFS for storage and MapReduce for processing. So except Zookeeper, almost every Zookeeper and Hue, almost all the services in Cloud Data Manager uses HDFS. So storage, HDFS. There will be no other storage. Okay, so Sqoop import No, you need not write API in MapReduce to export or import. That is not true. You can do that if you want. If Sqoop is not performing as per your expectations, you can do that. That's what we will get into those details when we actually do the demo. I will explain that. Okay, so that is a very good question actually. So Sqoop import will actually get the data from source into the HDFS, and when you actually give the command like this, so this is the sample command, okay, and import is to copy data from your database into Hadoop. So here we are specifying the Hadoop target directory. So Manoj, you will use commands like this to actually run the Sqoop imports or Sqoop exports. You will not use Java programs for most of the stuff. So this is the target directory, and you have to give the username and this JDBC URL. If you are using MySQL, you need to provide the JDBC URL along with the database. So cards is the database, and this is the host name. Port number is optional if it is default port, which is 3306. If it is not a default port, then you have to even give the port number here. And then you have to tell the username and password, and you have to give the table name. So from this database, it will try to read data from this table, and then it will try to load the data into here. And while writing the data, we need to define the delimiter. So these two lines are the delimiters to write data into HDFS. Okay, so we will see the demo and then you will understand that, understand it in detail. So before copying, actually it will make a POJO class, plain old Java object, which will have getter and setter methods for all the attributes in this table, or all the columns in this table. That's how it knows, it keeps track of the structure of the table, and it uses that same structure while copying the data into this target directory. Okay. Sqoop import is to get data from conventional databases as well as NoSQL or document-based databases into Hadoop ecosystem. When we say Hadoop ecosystem, it could be a HBase table, it could be a Hive table, or it could be a plain HDFS directory. It uses MapReduce framework to load data in parallel, and the default is 4. Okay, so it try to use 4 threads in parallel to copy the data from the source to your target database. And first it will generate a custom DB writable class reading metadata of table. Then it will connect to the database. So it will actually connect to database twice. First it will connect to the database to get the metadata of table, and it will generate this DB writable class. And then there will be 4 connections to the database. As the default number of mappers is 4. It will try to connect to the database with 4 concurrent connections, and it will read the data from the database and split using this custom DB writable class, which is generated on the fly, and then it will load into HDFS. So there is an algorithm how it will actually divide the data into 4 mutually exclusive sets, which I will explain in a moment. Okay, so this is the split logic. If there is a primary key on a table, it will try to use the primary key of the table. It will get the minimum and maximum value, and then using that minimum and maximum value, it will compute the ranges based on the number of map tasks, and it will process mutually exclusive data in parallel. So let me do the whiteboard and explain the algorithm a little bit. So I'm going to applications and Coral. So this is for Sqoop import. Okay. Sqoop export, it will be significantly different. Not completely, but significantly different. So you have the database, okay, and then you have the Hadoop cluster. Whether you use Sqoop or Sqoop2, the algorithm is same. First, let me explain this, then I will come back to that. Okay, and then you will have a node where you have the Sqoop client, and you use this one to submit the Sqoop command. So what happens is, let's say you have table cards, not cards. Let's take some real world example. You have a table called EMP. And EMP ID or EMP number is the primary key. This is primary key. And let's say there are 1 million records. Okay, and the way it works is, when you submit the Sqoop job, it will first create the DB writable so that it can read the data in structured manner, DB writable class, so that it can read the data in a proper structure. And then, depending upon the number of mappers, the primary key, what it will do is, it will get the minimum and maximum value of the primary key. So let's say the minimum value is 1 million. Let's say we have 1 million employees in a company, and the minimum value is, let's say it starts with 10 digits. Okay, let's say it is 1 0 0 0 4 5 6 7. Let's say 7 digits. Okay, let's say this is the minimum value, and maximum value is 9,999,999. So let's say this is the minimum value and this is the maximum value. And when you actually run the command, you can, by default, it try to use the 4 mappers, but you can customize it by using number of mappers spread. And if you give 10, what will happen is, first it will read this minimum value, and it will read this maximum value. So you have 1 million as minimum value, and 10 million. I'm getting a call, just give me a minute. Okay, so you will get the minimum value and maximum value, and as you have given 10 as mappers, so between 1 million and 10 million, there are 9 million. The delta between these two is almost 9 million. Okay, so this 9 million will be divided into 10 buckets. So from 1 million to, let's say it starts with 0 0 itself, all zeros, and then the maximum value is 7 nines. Okay, and now you have 10 million delta. So if you use 10 as number of mappers, if you use 10 as number of mappers, it will get the delta first, and then it will divide by 10. So as we get 10 million as delta between these two values, maximum and minimum of the employee number, it is 10 million. By dividing by 10, you will get 1 million. Okay, so now from all zeros to 1 million, it will be treated as one bucket. So all the employee IDs that falls between all zeros to 1 million will be considered as one bucket, and then 1 million, 1 to 2 million, it will be second bucket, so on. So depending upon the number of values, it will divide and then it will add, it will compute the ranges. This is called as computing the ranges. So now if you see the logic, you will end up getting the mutually exclusive data sets of 10. And so that there will not be any duplicates while it is actually copying data into HDFS. That's how it will compute the ranges, and it will read the data using 10 concurrent threads from the database and load, and it will load into HDFS as part of the Sqoop import. Okay, this is very important to understand. If you all don't have any questions, I will now explain some issues with this approach, and you have to be aware of those issues. And there are too many issues. You have to tackle them case by case, and then you have to come up with the solution. But this is the default behavior of Sqoop import. Okay, so what do you want me to explain? So it's simple. You have so how it will do is employee table have employee number, which is a primary key. Primary key means all the data is unique. So one employee ID will not be repeated. Any given employee ID in the table will not, or employee number will not be repeated twice. Okay. So there are 1 million employees. Let's say there are 1 million rows in the table, and you want to copy. Okay. Now, let's say when you actually within the table, employee number minimum value is all zeros, and maximum value is all nines. So which is 9,999,999. So the delta is 10 million. Okay. So when you use Sqoop import, the default behavior is depending upon the number of mappers. So this 10 is number of mappers. Okay. First, it will compute the delta of the minimum and maximum value of the employee number. So maximum value is 9,999,999, and minimum value is all zeros. So the delta between the two is 10 million. So if you subtract them, it is close to 10 million. And you have 10 as number of mappers. So if you divide this 10 million with 10, the outcome will be 1 million. So using this information and the minimum and maximum values, it will compute the ranges. So the first range will be all zeros to 1 million, so whatever is the value. And then the second range will be +1 of the ceiling of the first range, or higher limit of the first range, and it will add 1. So the lower limit of the second range will be 1,000,001, and the higher limit will be plus 1 million, which will be close to 2 million. Similarly, the third was actually this one will be not 1 million. This one will be 0,999,999, and then this one will be 1 million, and 1,999,999. So it's pretty simple. So depending upon the difference, okay, now you got it. So now, okay, anyone have any question in this? So it's pretty simple. It will just compute the maximum value. It will compute the delta between the maximum value and minimum value, and divide by number of mappers, and then it will compute the ranges so that the data is pulled mutually exclusive. Yeah, go ahead. Go ahead, Chintan. What is the question?
So Durga, let's say we copied once all the 10 million row. Now there are 1,000.
There are only 1 million rows. Even though the delta is 10 million, there are 1 million rows. Using the 10 threads, we are copying 1 million data.
Okay, so let's say 1 million row, we copied that one. Now there are few more rows into the RDBMS DB, which is
okay. Okay, you are getting into the delta. I will come back to that.
okay.
First, let me explain the issue with this algorithm. Then we'll talk about delta. Okay, if you have any issues, if you have any questions with this logic, let me know. Okay, so now what are the issues? As I mentioned to you earlier, we have only 1 million rows. And if you are familiar with, most of you are experienced, and whenever you deploy the application, you go with smoke test in production. And to do the smoke test, you will create some fictitious employee IDs. And typically, those fictitious employee IDs will be like all zeros, all nines, which will not be a typical standard employee number. And you will test the entire application with some basic testing, and this is called a smoke test. So when you have these things, let's say now you have 1 million records. Because of those kinds of issues, like fictitious or fake employee numbers for your smoke test, there can be outliers. Okay, it is called as outlier. And let's say even though you have 1 million employees, and your actual employee IDs start with some, let's say, somewhere in 3 million. Okay, and you have 1 million records, so there will be attrition in the company, and because of that, probably 2 million employees IDs might have generated. So it might have started in 3 million, and it might have ended with 5 million. So even though your minimum value is 0 and maximum value is 10 million, most of the data, almost 100% of the data is between 3 million and 5 million, right? So what happens when you actually try to pull the data using 10 mappers? Only 2 mappers will be doing the work. Rest of the 8 mappers will just read one or no records, and most of the work will be done by just 2 mappers. So because of this outlier issue is big, and it will skew the performance quite significantly. So this is one issue. And the other issue is, let's say you are dealing with data warehousing, and typically date IDs will be represented like this: year, month, and date. Okay, and as you are aware, your years means after 2014 0131, it will directly go to 2014 0201. Okay, and then again after 0228 or 29, it will go to 2014 0301. Again, it will go till 2014 0331, etc. until 2014 1231. So even this let's say you have a huge table, huge fact table, and there is typically data warehousing tables will not have primary keys. In that case, what you have to do is you have to specify split by clause. Okay, like this. You can set split by clause. Typically, you should have the indexed column here. So in fact table in relational database, the data ID might be indexed in most of the cases if you are querying data on date dimension. So you can use split by clause, and you can use number of mappers more than one, even though there is no primary key on the table. But again, the issue will be the skew of the data set. Even though you use 20 or 30 mappers, only 4 or 5 mappers might be doing the entire work, and rest of them will just finish off immediately. So the skew is pretty, the impact of skew is pretty big in most of the cases. So you have to come up with custom solutions for those kinds of stuff. For outliers issue, you can actually, when you run the Sqoop import, you can define the where condition. So if you go to the Sqoop user guide, let me go to Sqoop user guide and explain a little bit. So you can click on Sqoop user guide. For Sqoop2, there is no proper user guide, but for Sqoop1, this user guide is pretty good, and you can. So there is a where clause, and you can specify during import, and you can tell that employee numbers should only be 3 million and 5 million. So using this where condition, you can actually address the outliers issue of those fictitious employee numbers. But for the other problem, which I have explained just now, based upon the data IDs, it might be a little bit tricky. You might have to create a view on the table and somehow make sure that data is evenly distributed across multiple, across all the threads. So you have to think through the problem, and you have to leverage all the features that are provided by Sqoop and come up with the solution. So in this case, what you can do is you can create a view which will compute some. Let me show you. Where is it? So in this case, if you actually pull the month, which is 01, from this from this table, and create a derived column as part of the view. So instead of directly querying from the table, you can create a view where the last column could be, one of the columns could be a substring of the data ID, comma 1, 2, 3, 4, 5, comma 2. So from 50 characters, 2 characters you can pick, and most likely in what is it? In when you do these kinds of things, again, to address the performance issue, you might have to index. You might have to create a functional index on the table. So you have to think through the problem, and you have to leverage the database features, and also you have to leverage the Sqoop features, and you have to make changes accordingly. Or another solution could be, instead of running one Sqoop job, you can run 12 Sqoop jobs, each one processing a month of data using one thread. So you can get the parallelism manually. So you have to think through. You have to be creative based upon the problem, and you have to come up with the solution. But thinking through the problem and coming up with the solution is the better approach, rather than developing a MapReduce job for most of these problems. Okay, so over time you will get a reliable framework for your enterprise. So now let me see if I have slides for Delta. Yeah. So now Chintan's question: what if data is changing in the table? So there are multiple ways you can get the data. If you have a date column on the source table, and if you can, you need to keep track of what all data is already migrated, and based upon that, you can actually program. You can develop a shell script which will look up into a table to determine what all data is already migrated, and based upon that information, you have to generate your Sqoop commands in an automated manner, and then using that information, you can come up with a process where you can pull the delta And out of the box also it provides certain certain features like last value. You can provide the last value which is imported, but to provide that information, you have to keep track of that information somewhere. It could be a file in Linux, or it could be a log table in traditional databases, where you can look up into the table, get the last value from the table, and generate the Sqoop command on the fly, and all the process needs to be automated. So using those approaches, you can do the incremental loads after the baseline is loaded into the HDFS. Okay, now we will talk about Sqoop export. So a Sqoop import is from traditional databases to Hadoop, whereas Sqoop export is from Hadoop to databases. Okay, let me. I will stop the video now, and then I will create a new video for Sqoop export.